finally, about queues. So the structure queue represents the queue. Elements are added to the end of the queue, but are taken from the beginning. Okay. And the priority queue is essentially the only standard implementation of the queue interface if you don't count the linked list. Okay, so linked list is also implementation of queue. All right. So just to show you about a queue, how it works. So here we have for the linked list queue is the interface. And here we have the priority queue or the linked list. So let's take a look. Before doing this, let me just output everything. So again, we have the method add to add that elements, and here we are adding in a queue. So the same order that we added is the order that we output. Okay. So we added Java data structure, algorithms, and graphs. It's the same output right here. And for the priority queue, it would be basically the same output. Oh, it's actually sorted by the name, so the natural order, not the insertion order. Okay, so priority queue based on a comparator, and since it is string, so the natural order right here. So algorithms, graphs, data structure, and Java. So again, similar to what we did with maps. If you want to keep the insertion order, use the linked list. So insertion order, and here you can sort the element. Okay. And since we didn't provide a comparable criteria, a sorting criteria, so it takes the natural order. Okay. Let's try to see if we can add a comparator right here. Yes, we can add a comparator. So new comparator, and I'm going to compare by the length of the name. Okay. Length minus 02 length. Okay, so here we have the smaller on length first. So Java, graphs, algorithms, and data structure. So we just provided the criteria of comparison based on the length. So the smaller length comes first, and then the biggest, the biggest come later. Okay. And if we didn't provide the comparator, so it takes the natural order. So I'm gonna remove this because it was just another example of using comparator just to establish a link of from what we saw on the maps. Okay, so priority queue and linked list. All right, and to remove the elements, we have the method poll. Okay, so here I am defining that while it is not empty, we are going to poll the element. So the poll, it retrieves but removes. So retrieves and removes the head of the queue. Okay, so it's like in waiting list. then we remove all the elements. The output is really similar, but the difference is actually that, let me comment right here again, and then print the queue size. And again, if I do this, so here it should be 4 and then empty, okay? So if we iterate over like this, we are just reading the element, but if we call the all method, we are actually removing. So after all, the result is 0, the size is 0, okay?